What would happen if the largest objects in the universe collided? Imagine this. Two galaxies are flying toward each other at several hundred kilometers per second. Sounds like a catastrophe. But here's the strange part. When they collide, almost no stars will actually crash into one another. The distances between stars are so enormous that the two galaxies will pass through each other like clouds of smoke. And yet, it will still be the most violent thing that has ever happened in their region of space. Because gravity does not care about emptiness. Listen, we're not really used to thinking about collisions on a cosmic scale. A collision is something that happens to cars, billiard balls, or to a person and a doorframe at 3 in the morning. But the universe contains objects so large that our brains literally refuse to process their scale, and some of them are heading directly toward each other right now. And once you realize what happens when they meet, the night sky stops looking quiet. Let's start small. A collision between two neutron stars. And yes, I mean small, completely seriously. A neutron star is the corpse of a star that was once 8 to 20 times more massive than our Sun. It exploded, threw off its outer layers, and left behind a core that collapsed under its own gravity until it was compressed to the size of a city. More mass than the Sun, a diameter of only about 20 kilometers. A teaspoon of that material would weigh roughly 10 million tons, not kilograms. Tons. And this city-sized star is spinning. Some of them rotate 700 times per second, more accurately than any atomic clock humanity has ever built. Now imagine two of these objects locked together by gravity, orbiting each other for billions of years, slowly drawing closer. Losing energy by emitting gravitational waves, ripples in space-time itself, predicted by Einstein mathematically a century before we learned how to detect them. And here's the thing. When they finally collide, it happens in milliseconds. Milliseconds. Two objects, each heavier than the Sun, merge into one. More energy is released than our Sun will emit during its entire 10 billion year lifetime. And I'm serious. This is not a metaphor. We observed it. On August 17, 2017, the LIGO Observatory detected gravitational waves from the merger of two neutron stars 130 million light-years away. Just 1.7 seconds later, telescopes around the world recorded a burst of gamma rays. Then came the kilonova, an explosion capable of creating heavy elements such as gold, platinum, and uranium. Every atom of gold in the universe, and every atom of gold on your finger if you happen to be wearing a ring, came from collisions like these. Not from ordinary stellar explosions. From this. Okay. But two city-sized stars are still not the biggest things out there. Let's go higher. Betelgeuse. You've probably heard the name. A red supergiant in the constellation Orion, that bright orange point in the hunter's shoulder. Looks harmless enough, right? Just another star. But if you placed Betelgeuse where our Sun is, its surface would extend roughly to the orbit of Jupiter. Earth would not be nearby. Earth would be inside the star. Deep inside it. And here's where things get uncomfortable. Betelgeuse is dying. Right now. It's unstable, pulsating, and shedding material into space. Astronomers know it will explode, maybe in 100,000 years. Maybe it already has, and the light simply hasn't reached us yet. Betelgeuse is about 700 light-years away. That means everything we see today is actually 700 years old. The star could already be gone, and we would still be looking at its ghost. When it finally explodes, and it will, it may become visible during the daytime. For several weeks, it could shine brighter than the full moon. Now imagine two objects like that colliding. As rare as it sounds, collisions between supergiants do happen. And what follows depends on the mass involved. Either a new, even more massive stellar monster forms, or the merged object collapses almost immediately into a black hole. Sometimes both happen in sequence, a brief merger followed by collapse. The explosion can become so powerful that, for a short time, it outshines an entire galaxy containing hundreds of billions of stars. This is called a hypernova. One star, one death. Brighter than everything around it. But even that is not the largest scale. Let's go higher still. There are objects called quasars. Here's the important distinction. A quasar is not a star. It is not even a galaxy. It is the active core of a galaxy where a supermassive black hole is consuming matter so rapidly that the disk around it heats up to incredible temperatures and emits more energy than 1,000,000,000,000 suns. 1,000,000,000,000. A single quasar can outshine entire clusters of galaxies, each containing billions of stars. We can see them from billions of light years away because they are bright enough to be visible across a significant fraction of the observable universe. So what happens when two quasars approach each other? This isn't theoretical. Astronomers have observed pairs of quasars moving toward merger. Their host galaxies collide. The supermassive black holes at their centers begin orbiting one another for thousands, then millions of years, gradually spiraling inward. And there's one detail that genuinely stopped me when I first learned about it. At some point, there is a problem. It's called the final parsec problem. Two massive black holes can spiral closer and closer together, only to stall at a separation of about 1 parsec, roughly 3 light years. At that distance, gravitational waves are not yet efficient enough to remove energy quickly, and stellar interactions have already done most of the work they can do. We know black holes eventually merge because merged black holes clearly exist, but the exact mechanism that gets them past this barrier is still not fully understood. It is a real open problem in modern astrophysics. If you're still here and your sense of scale hasn't started cracking apart yet, subscribe, because it only gets stranger from here. And leave a like if you think the algorithm should share this existential damage with someone else. Okay, when two supermassive black holes finally merge, and we know they do, the released energy isn't primarily an explosion. It isn't light. It becomes gravitational waves. Ripples racing outward at the speed of light, stretching and squeezing space-time itself. LIGO can detect changes in length smaller than 1,000th the diameter of a proton. Think about that. We are measuring distortions smaller than subatomic particles across instruments that are kilometers long and using those measurements to study black holes billions of light years away. But there is one more level: galaxies. The Andromeda galaxy is moving toward us at roughly 110 kilometers per second. In about 4.5 billion years, it will collide with the Milky Way. And this brings us back to where we started. Stars will almost certainly not collide. Space is simply too empty. But gravitational tides are another matter entirely. Both galaxies will stretch, distort, and pull long streams of stars into intergalactic space. They will pass through each other, swing back around, and collide again. Computer simulations suggest that after billions of years, the two galaxies will merge into a single giant elliptical galaxy, informally nicknamed Milkomeda. Our Sun will probably survive the event. It may be thrown into a completely different orbit around the new galactic center, but it will likely remain intact. Although, to be fair, by that point the Sun itself will have become a red giant and swallowed Earth. So the galactic collision is probably not our biggest concern, and somehow that makes the whole thing feel both less frightening and far stranger. Go back to that moment when I said a quasar can outshine a trillion suns. Sit with that for a second. We look at the night sky and see points of light. Some of those points are stars, some are entire galaxies. Some are so distant and so bright that their light allows us to map the structure of the universe when it was only a fraction of its current age. Every time you look up at the sky, you are not just looking across space. You are looking through time, billions of years into the past, at objects that may no longer exist, at events that ended before Earth even formed. And somewhere out there, in the darkness between those points of light, two quasars are slowly orbiting one another. Two supermassive black holes, each billions of times heavier than the Sun, sitting at the centers of merging galaxies. They are drawing closer, incredibly slowly, over millions of years. And when they finally merge, space-time itself will shudder. The wave will travel through everything. Through you, through this room, through Earth. You won't feel it, but it will pass. That is happening somewhere in the universe right now. Right now. And somehow we have learned how to hear it. Before we wrap up, tell me in the comments, which collision blows your mind the most? The fact that the gold in your jewelry was forged in a neutron star merger, or the idea of two supermassive black holes reshaping space-time itself?